Assalamualaikum. Hi, my name is Muhammad Amin bin Muhammad Razin. My meeting number is 211301483. Today I would like to representation about what is the TinyOs. TinyOS is a open source embedded operating system. It is designed for a network and memory concerning the system. It mainly focus on low power wireless sensor network system and Internet of Things, which is the IoT. Consequently, TinyOS is a lightweight enough to satisfy the requirement of embedded device with not so powerful microcontroller with a small memory and they operate on the battery. TinyOS was created at Berkeley University in 1999 and later developed by many companies and university. TinyOS and its application are writing using NESI. NESI is a structure component-based extension of the C language. Now we will discuss the 5 basic concepts of NESI. The first one is the separation of the construction and composition. This is achieved by the fact that all programs in TinyOS are big as component and then they are assembled to form a whole program. Component have an internal concurrent in the form of tasks. A component may be called via its interface. Second is the specification of the component behavior using a set interface. This means, in other words, the provide interface is used to representing the functionality of particular component. The third one is regarding the bidirectional interface. This implies the interface define the function which can be implemented by both the command and event. This provide the benefit that a single interface can represent a complex interaction between the component. Fourth, the static linking of the component with each other and via their interface. This ends the runtime efficient, promote the reverse design and allow for the better static analysis of the program code. Finally, a whole program compiler in the NESI code is generated by the whole program compiler. Instead, the block therefore is better for the code generation and the analysis after the introduction. Internal. I hope you have a main idea of TinyOS. Now we go into the internal of the TinyOS feature and advantage. Absolute size compared to other popular embedded wireless sensor network, TinyOS requires a minimal RAM and room from the performing a basic task. It needs less than 1 KB of room and 4 KB of RAM. Now you may wonder how it can happen. Previously, I mentioned the whole program compiler in NESI. It is used to remove the code and applies cross-component optimization to remove redundant operation and minimize the overhead of module crossing. In TinyOS, the context switch overhead correspond to both the cost of task scheduling and interrupt the handling overhead. The interrupt overhead consists of the both switching overhead and function overhead of the handler, which vary with the number of save the register. In a constraint, the other traditional multimedia application, sensor network application are different in terms of the time critically of time. Instead, the crossing the priority scheme to allow the correct ordering of the task. TinyOS use a simple scheduling to the schedule based on the set of deadline. TinyOS with an SC compiler support debugging and help detect the race condition. In order to do the synchronous and asynchronous code considered in the TinyOS. In order to give you better understanding of this process, synchronous and asynchronous code will be explained. Synchronous code or AC is the code that is only reachable from the task, and asynchronous code AC is code reachable from the at least one interrupt handler. The primary goal of TinyOS allow the developer to build the responsive and concurrent data structure that can safely share between AC and AC for the component. Often have a mix of the AC and the AC code. As a result, there's a potential cost of the race. It's clear that non-preemption of almost eliminate is between tasks. However, there are some cases of the potential race between AC and AC. Between AC and AC, there are two options to avoid in such a case. The first one is convert add all the conflict code to task only for AC. The second option is to use atomic injection to update and share state. Next, I will discuss about the ATIS message, which can be considered to main communication abstraction model of the TinyOS message. A small packet about 36 byte associated with the 1 byte handler ID. Now you might go to may wonder how the ATIS message. Let's us see the not dispatch a message using an event to one or more handler that register to receive message. Handler distance is carried out using static wiring and parameterized interface. Moreover, the single hop datagram protocol and field communication interface are provided by AM. High level the protocol providing multi-hop the communication and readily the bit on the top of the AM interface. Example 1, parking lot monitoring system. The function parking lot monitoring system use a Raspberry Pi for the embedded system project, which is developed with the aim of helping the pupil for view the available parking space inside the mall without the need of checking it directly. The system will reduce the hassle of the checking the available parking space one by one on each layer of the parking space, which is provided by the mall. This will also reduce the time needed to find the parking space and somehow save the vehicle fuel by a little bit. For the future investment, which use the camera model V2, RFID, NFC, MFR CF22 or PN532, and use a Bluetooth low energy BLE module HC05 and HC06. Example 2, smart home gardening system. Function: a well-designed smart home gardening system provides an intelligent and automated solution for individuals to grow health plant in their home with a minimal manual intervention. It combines technology, data analysis, and automation to create an efficient and user-friendly gardening experience. For the feature and assessment, use the pH sensor, light sensor, soil temperature sensor. Conclusion from the TinyOS: for small device, TinyOS is made for small wireless device, especially those in the sensor network. Simple, efficient design. It's focused on being easy to use and work well on the device with the limited power and memory. Tool for developer: it provide tool for developer to create application for tiny gadget like sensor. Unit program organization: TinyOS organize a program in unique way for efficient execution on a small device. Open for all. Anyone can use and improve TinyOS since it open source platform.